Hi class, this is Jeff. So we're going to look at deciding whether a Lewis structure satisfies the octet rule. So we want to decide whether these proposed Lewis structures are reasonable. And so first of all, we need to figure out the total number of electrons for the that are available for this structure. So we would go to the periodic table, and oxygen is in group 6A. So that means it has 6 valence electrons. So then we'll take, and we have 6 valence electrons. So we have oxygen is 6 and 6 and 6 because there's 3 oxygens. And so that's 18. And so they show us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So they're missing some electrons. Okay. And it's not the exact, they didn't follow the proposed Lewis structure rules either. So is this reasonable? So actually, you know, we're going to call this no, because it doesn't have the correct number of valence. And so it needs 18. Okay, and then let's look at how to draw this structure. Okay, so we have 18 valence electrons. So we're going to take them, spread out our 3 atoms, and then we'll connect them with a pair of covalent bonds. And so we have 18 electrons, and then we use 1, 2, 3, 4. Okay, so then minus 4, that gives me 14 to remaining. So then I fill out the outer atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I used up 12, I have 2 remaining. So then they can go to the central atom. So I put 2 here, and then that means I have none left. Okay, and then I check the octets. So I got 2, 4, 6, 8, 10, 12, 14, 16, and 18. Okay. And then, so I have all my 18 electrons. And so then the octet on this oxygen is 2, 4, 6, 8. And this one's 2, 4, 6, 8. But this one has 2, 4, 6. So we need 2 more electrons. Well, at this point, we're out of electrons. So we can change that by adding a double bond there, and then this removes these 2 go into there. So our configuration looks more like this. Okay, and so this is a bent shape because this pair of electrons that are unbonded are going to force these electrons in the bonds downwards. So this is going to be a bent shape to this. Because you don't see this, you'll just see this kind of this shape like that. Okay. All right, so that's the first one. And so the second one is hydrogen and bromine. So bromine is in group 7A. So it has 7 valence electrons. So Br has 7. And then hydrogen has 1. So we have a total of 8 electrons to work with. So what do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8. Well, that is correct. And so no, so they're correct, but it's not not put together properly. So and so it's this one because it doesn't satisfy the octet rule because bromine has to have 8, and it does. So it has 1, 2, 3, 4, 5, 6, 7, 8. But hydrogen, it can only have 2 valence electrons. So it has 1, 2, 1, 2, oh my goodness. Okay. So 1, 2, so this hydrogen. Okay, so there's 1, 2, 3, 4. And so the most that hydrogen can have for its octet is 2. That's the octet for hydrogen is only 2. Okay, so we need to rearrange that. So we have 8 electrons. So let's put bromine, and we'll use 1 pair of electrons here. So that'll be 1, 2 that have been used up. So that'll be 6. So then we can put 1, 2, 3, 4, 5, 6, and that's going to be 0. And then there's nothing needs it over here. So this should be a single bond between the bromine and the hydrogen. So that is answering that. And then the third one with nitrogen, nitrogen is in group 5. So nitrogen has 5 valence electrons, and hydrogens, there's 3 with 1 valence electron in each. So that means 8 for that one. So then we'll connect these together, surrounding it. And then, so then we put a bond there, bond there, bond there. So that's 1, 2, 3, 4, 5, 6. And then we have to put 2 above that are not bonded. So that's 8. So then if we look at this, so we get a pair of electrons up there. Okay, so nitrogen now has 1, 2, 3, 4, 5, 6, 7, 8. That's satisfied. And then hydrogen has 1, 2, 3, 4, or 1, 2, 1, 2, 1, 2. Okay, so the structure there, this is pyramidal. And so we have a kind of a nitrogen with the hydrogens on top. And so then there is a hydrogen down here, one back there, and then this one kind of goes back into the paper or the screen. So it stands on a tripod with the nitrogen above that, so it's like a pyramid. So it's called pyramidal shape. And so then that is the structure. And so it was correct. Yes, it has the correct number. And it has the correct number of bases. So this one is all yes. So that one worked. So let us know if you have any questions. Thank you.